Hello everyone. In today's lecture, let us discuss about an assembly language program of 8086. Assembly language programming of 8086. So here a simple addition program I have considered in order to explain the assembly language programming. So here the problem statement is we need to add two 16-bit numbers, and the program starts from the memory location 2000, and the two datas are being given in two. If we want to add, we need two numbers. The two 16-bit numbers are given in the location 3000 and 3002. Let us see why this 3001 is missing here later when we are explaining the program. And the result we are writing in the program that I'm expecting the result in the location 3004 and 3006. So this is the problem statement. The address was being given, where the data inputs has to be given was also mentioned, and from where I can retrieve the data was also been mentioned. Now I have to write. We know all the instructions of 8086. We are going to write a simple program. First, let us see what. So this is the input data, what I am going to give. See, the question says that in 3000 and 3002, I have to given the inputs, right? So see, these inputs are 16-bit data. And so this 16-bit data, for storing the 16-bit data, I need the registers AL and AH together. So this will be AL and this will be AH. Similarly, this will be BL and this will be BH. So this is 8-bit, this is 8-bit. All together we have the 16-bit. So this is one 16-bit data and this is another 16-bit data. That is why one 16-bit data is mentioned in the location 3000 and the second 16-bit data is mentioned in the location 3002, because 3001 will be used by the first data itself to store the higher order bits, right? That is why we give the inputs in the address location 3000 and 3002, not in 3001. Okay, so now coming to this, now we have said that I want the same reason as why here two locations have been occupied for the results also. So when I add these 16-bit data, I'll be getting 16-bit data along with a carry. So in order to store the 16-bit data, I need these two locations. This is 8-bit and this is 8-bit. So because since I need these two locations, I'll be storing the result in 304, and then the carry I'll be seeing it in 306. Okay. Now let us look into the program. It's a very simple and basic program, and we'll be using simple basic instructions of 8086 in order to write the program. So if you see the 8086 addition program, if we want to add, we need two numbers. That is a basic principle. So I have to get two numbers. So already in the question it was mentioned that the two numbers has to be given in 3000 and 3002. So see, in the location 3000 and 3002, I'll be having the datas, right? Here I cannot add this one, right? So what I'm going to do is I'm going to, using move instruction, I'm going to move the data in 3000 to AX and 3002 to BX. Now you see AX and BX denote 16-bit registers, so we are adding 16-bit numbers. Now add AX comma BX, so which is very simple normal addition, and now the result will be stored in AX and BX will be added, and result, this will be always the destination in 8086, and so result will be stored in AX. So see, from AX I can retrieve. Now in the question, in the problem, it was given that the result has to be displayed in the location 3004. So now it is available in AX, and now I have to move it to 3004, right? And I cannot view these registers, so that is why through this memory addresses we'll be giving it to the registers. So and then see, a carry will be generated, and see, when I add these two numbers, only I'll be getting the result in AX. I don't know why the carry will be, right? So what I have to do is initially I have to initialize a register for carry. It could be any registers, but normally, generally, a C register, that is the counter register, is being used as carry registers. But there is not any rule like that. AX and BX are used for normal addition purposes, and so CX is used for, so C is counter registers. And so see the CX I am initializing it as 0. After addition I am looking that whether any carry is there. If any carry is there, I am asking it to increment the CX register, and CX register will be getting incremented. If there is no carry, then I need not to increment CX because already it is 00. So I'll be skipping this step and I'll be coming to the address 2010, wherein I can transfer the data. Simply, I do not need to, I can skip this step if there is no carry. That is why a label, that is address location where. So this is the conditional instruction, jump no carry, right? So after complete, so I've added two numbers, I've stored the two numbers, the carry also I've initialized, and carry is also been stored. Now I can quit the program, I'll be getting the answer. So with the machine control instruction halt, I can quit the program. So after execution, this will be the result in this location. And here, for your assessment, mention the addressing mode of add AX, BX. For addressing modes, please review my videos in the previous lectures. And similarly, halt is a dash type of instruction as a machine control instruction. Okay, and so thank you.